What we're doing a lot now is mostly improving existing processes, right? We take a process, every step of the way we automate or we improve the productivity. But what we really need to do and can do with AI is rethink the whole process end to end. If you can describe a problem in the most precise way, then you can automate the resolution of that problem. And that mind shift needs to happen. It's not just about solving things, it's about understanding what the important problems to solve are. People on the ground are going to be the ones not only defining, but building their own solutions. And therefore, the whole aspect about learning becomes incredibly important because you need everyone to be able to understand how AI and related tools can help them in their day-to-day job, to automate parts of it, to rethink the process as a whole. It's about machines learning and it's about human.
This is Exec on AI, the podcast by Exec for Exec working on AI. This is season 2, and we really want this podcast to be concrete, to be really pragmatic for leaders. So we're going to be talking about real case study, real lesson that execs have been learning. So just for a little bit of context, we have Mihir, head of AI at Engie, today with us. Thank you.
Thank you for having me. Great to be here.
And Mihir is so much more than head of AI at Engie. So he's been a researcher at MIT about AI impact in music, so how the brains understand music. He has co-founded 2 startups in AI in the Silicon Valley. He has launched the Power by AI conference that we'll be talking a little bit more later. He also speaks about AI, teach AI, sits on technology startup boards on the AI topic. So we have so much to discuss today. Let's jump right into it.
Sure.
So you work in different setup, different industries. I'm just wondering, what's the common thread that led you to dedicate your career into AI?
So yeah, like you're saying, I've been working in various industries throughout my career. Started in the finance industry, then worked in consumer electronics, semiconductors, audio, automotive, music technology, and then the energy sector. Very different sectors throughout my career. The common thread has always been some variant of artificial intelligence, AI, machine learning, or initially in my career, it was DSP, digital signal processing, which is a way to process audio, video, multimedia, those kind of things. And I think the common thing throughout the different experiences have always been around science. So understanding humans and understanding our place in the universe through understanding our brain, how our brain and mind function, making artificial models, synthetic models that represent how we process information, and using those models to better understand how the brain functions as well.
Okay.
So it goes both ways, and applying that to various industries at the cutting edge. So for me, it's always been very important to have an impact from the science. So the best way to do that is through technology innovation. And I've always sought domains of applications where there was a gap, where AI or digital signal processing or embedded software, all those technologies weren't making a big impact, and seeking to do that. And once the field matured, I sort of moved on to other fields.
It's interesting, the link between the brain, the reality, the world that we're all living, our place in the world. I'm just wondering, if you had an 8-year-old in front of you and you had to explain what you're doing at Engie as head of AI, how would you describe your job?
So as an 8-year-old, your task in school, in life, generally is learning, right?
Yeah.
You absorb every kind of sensory input you have, visual, auditory, etc., touch, and you make a representation of the world in your mind. That's what you're trained to do. So what I'm trying to do throughout my experiences, and specifically at Engie, is to make machines learn in the same way that humans learn. So they can learn about the world, the weather, the solar patterns, the wind patterns. They can learn about the way we live our lives and consume energy. That's how most of our economic activities happen, is through usage of energy. And matching the production of energy to our consumption behavior and patterns is what is the most important at this time, is making sure that we consume better, we lose less production in terms of energy supply, so that we can better match our consumption with our production. And making machines learn those patterns is something that AI can help with. So we have learning how machines behave, and that's machine learning, those kinds of technologies that have been around for several decades. And with new AI technologies and generative AI, we're learning how humans learn. And putting those two together is super important because economic work has always been between the collaboration between machines and humans, and where the cursor has been moving between, you know, what we automate, what do we leave to humans to do, what's the most creative, value-added part that humans can keep in their hands, and making machines help humans better perform their jobs, automate processes is what AI and digital technologies generally is about.
It's so interesting because I know that some people are so afraid when we talk about AI because it sounds like this magic box, you know, that we want to make human. And I love that you're saying we want to make the machine learn as a human. So there are processes that we are following. Can we share like a concrete case that you've implemented and that really helped to accelerate, especially in the sustainability topic or the movement to zero carbon that you're looking for at Engie?
I think it's really important to know that AI is not just ChatGPT and you know, generative AI. As a field, AI has been around for 70 years as a modern technology, and we still use algorithms that date decades in machine learning. So one of the examples that we have is in operational efficiency. How do we make our operations more efficient so that we produce just as much as we need? One of the things that has shifted in the past decade in the energy sector is the fact that we use a lot more renewable energy. And renewables like solar and wind, they're intermittent energy sources because you don't always have sun, you don't always have wind. So sometimes you produce energy through renewable assets, sometimes you don't. And what happens is that we have some other assets like gas power plant, for example, that use natural gas or that use greener gases these days, that can be switched on to overcome the lack of energy production coming from renewables. In the past, it was the opposite. We would use gas power plants, for example, we would switch them on, and after 6 months, we would switch them off and maintain them, change some pieces, and make sure that it runs for the next 6 months. What's happening now is that we switch them on and off multiple times a week, multiple times a day sometimes, just because we need to compensate for the lack of energy. So in that way, the equipment that is part of the renewable, the gas power plant undergoes some stress on these equipment that was not designed when those plants were built, because they were built to be switched on once and then switched off after several months. So the fact that we can now have a model that looks at sensor data coming from those equipment and understands how these equipment are degrading so that we can predict when they're going to fail and schedule a replacement or maintenance ahead of time so that we're not surprised by the fact that one equipment will fail. And if an equipment fails, if a power plant fails, then we have a lack of supply, we have penalties associated with that. So that's a problematic situation. So using AI algorithms can really help in compensating and having a greener energy mix in our grid.
I'm just trying to understand how you end up with this kind of projects. We already know that this second energy exists. So how did you come up with this project about sensors and about, you know, switching on and off? How did it happen?
So I joined Engie 6 years ago. And one of the happy surprises that I had when I joined the company is that we had power plants which had sensor data dating from 10 years before. So they had instrumented all their power plants with sensors, captured that data, stored that data in data lakes. They were quite advanced in that regard.
Because you joined as a chief data officer, right?
Chief data officer.
So you knew all the data there.
So we looked at all the data that was available, and there was quite a treasure trove of data. Not everything was well organized, not everything was usable and had high level of quality. But that was our job, to make sure that we understood what data we could reuse. And some of that data came from those gas power plants. And one of the tasks we had was to clean that data, make sure that it was usable, so that we could create this whole history of data trending the behavior of these pieces of equipment. So we worked with the temperature control valves, for example. We're now working with pumps and other types of equipment, and trend the degradations and understand when there was a failure that was unplanned, how they were behaving compared to how they were designed to behave. And learning from that data was critical and is always critical, a big part of how the models behave, more than the algorithms and the architecture of the algorithms themselves, is the data that goes into it.
So when you say you clean the data, is about having the same format, the same like What does it mean?
So concretely, it means, if you have a stream of data, so a time series that says, okay, every few seconds or milliseconds, you're capturing a data from one sensor. First of all, what is that data? Is it temperature? Is it pressure? What is it representing? What are the units and what's the range in which it makes sense? Because sometimes you have erroneous data that you have to clean out. And then how does that data compare and link with the other pieces of data in the same type of equipment? One thing that we've added in understanding that data is expert knowledge, is the fact that you can have experts, people who've been working on those power plants for decades sometimes, who really understand how these pieces of equipment behave and tell us that, okay, if this range is exceeded or the value goes above, then it means that there is going to be a failure mode that happens at some point. And so there's a large part of the new AI algorithms that are only based on learning from the data without expert knowledge. In the industrial sector, we still see that there's this need for convergence between the data that we get from assets and expert knowledge that we can bring in to help with understanding how that data behaves.
So you get data from all the sensors, and then you need an expert to come and add value, like analyze and kind of give meaning to the data?
So we can do it as a one shot. So the expert will come, explain how that data is supposed to be modeled, give us the range, etc. And then we model that into an equation or into some system that gives us, maybe a range, and we'll use that as a label to understand how the data behaves, so that I can train the AI model based on the expert knowledge and run it on the new data that comes in from the sensor.
And the AI model is the model that will capture the data from the sensor, or what does it do?
So the AI model, which is a typical machine learning model based on statistical and probabilistic models, will understand how the data trends based on historical trending. It'll say, okay, in the next 6 months, we expect that this piece of equipment is going to fail, is going to exceed a certain threshold. That threshold usually is defined by an expert. It's a fixed threshold based on certain conditions, operating conditions on the asset. And if we see that over the next 3 to 6 months, that piece of equipment is going to exceed a certain threshold, then we can schedule a maintenance and plan it ahead of time, source the equipment if it needs to be changed. So it optimizes the whole process into maintaining the assets.
That's so cool. And so basically you have the expert telling you, oh, there's actually this new energy that now you can be using on and off that we didn't do before, but we could be doing in the future.
It helps us green our energy supply, for example.
That's so cool. I'm going to move to the next question, which is, what do you see as the biggest opportunity today to make a measurable impact on climate and sustainability? Because I know these are the main two topics that you're really close to in the next maybe 5 years.
So one of the things that the energy industry has shifted towards is decentralization. Before, power plants used to be, in French, it's électrique or centrale. So it's very centralized, right? I mean, there's this idea that in energy production is these big assets that are going to produce energy or gas or whatever you're going to use, or heat or cooling, etc. And we as the consumers, whether we're individuals, industries, or territories, cities and public buildings, etc., that are going to consume that energy, what we're moving towards is a much more decentralized model where consumers become producers themselves. So people have solar panels on their roofs, industries produce their own energy. We can also store energy through our electric vehicle battery, for example, at home.
Some people cycle to generate battery.
Exactly. And we have big containers of battery systems that are now being set up around the world to store energy from renewable assets so that we can use it at the moment we need it, not at the time it's produced, but at the time it's going to be the most useful. So all these assets have to work together. So we call that flexibility. We need to have a much more flexible way to manage that energy, understand what these streams of incoming energy are, how the market reacts to it, what energy is going to go to the grid, what energy is going to be produced and consumed locally without going through the grid. When do we need to store energy? When do we need to sell it or to buy it on the markets? All these assets add a layer of complexity that we didn't really have before. And one way to deal with that complexity is to use AI and machine learning models to understand how these assets behave one with other, and to understand how we can use these assets in the most optimal way to reduce the carbon footprint of our energy usage. So AI is going to help in that. We have energy management systems that are going to be helpful in that regard. And AI algorithms, which are being developed along those lines, are very useful.
So what I understand from here is that basically what we're saying, people will have an easier access to energy because We will know how to store it, how to make it available when it's needed. I know we had a crisis like last year in France about not having
Around
enough
the world.
energy.
Yeah.
Yeah, that's true. And then we had too much, so we need to sell it. So what we're saying is we will have a better access thanks to AI because we know where we need it and how to store it better,
I
right?
think there's multiple layers. So one is on the consumption side, users, so individuals, for example, already can see what their consumption looks like compared to similar households. They can predict what the end of the month consumption is going to be. So there are other use cases where we can see, it's better to use your washing machine at this time. It's going to use greener energy. It's going to cost you less, etc. So these use cases are on the consumption side. We have this flexibility layer that should be transparent to the end users so that they don't have to care about where the energy comes from as long as it's green energy sources as much as possible. Most of the companies, Engie included, are working towards this 24/7 carbon-free energy. By 2030, one of the dreams is, can we, every time we use energy, make sure that the electron or the molecule that we are going to consume comes from a greener source of
And
energy.
now we have a face behind this project.
No, I mean, it's many people
I
working
understand.
around
Of
that.
course.
And AI is just one part of it. It's a very systems heavy approach that needs to be brought in. AI and technology is just part of the equation.
Yeah.
And another part where AI can help is the fact that we're increasingly in the industrial sector talking about systems of systems. It's an interconnection of very complex systems that traditional methods, which are equation-based, physics-based models or biological-based models for certain green energy sources like biogas, for example, are not computationally sufficient in terms of speed of execution to be able to do simulations or optimizations in real time. So in order to be able to do that, AI algorithms can help. Very specifically, for example, we recently developed a model for the production of biogas, biomethane, through the digestion of organic matter across territories where you put in corn and other organic matters that come from agricultural output. And we can use that to generate, through a digestion mechanism, some biomethane that goes back to the grid, that goes back to the gas network. And therefore, AI can help there, for example, to optimize the mix of different entrants that you have to have the optimal output of biogas and reduce carbon emissions.
It's definitely a really complex topic when we talk about energy. And I know this is one of the core topics as well when we talk about AI. It's the impact on the energy consumption. I feel like there's a lot of misconception that Exec might have. What do you think is the biggest misconception that they have when they think about applying AI to their business challenge?
I think the word AI is an umbrella word which encompasses a bunch of things. These days, we think a lot about artificial general intelligence, AGI, superintelligence, generative AI, or agents. And those kind of algorithms do consume a lot of energy. All the big projects of having massive data centers around the world that will consume gigawatts of electricity to train those models and then use those models for inference are definitely an energy sink that is going to increase in the next few years. We know that the new GPUs that are going to be used to train those models and be put into these data centers are going to use a lot of energy. So that's definitely one of the aspects to take into account. But on the other hand, a lot of the machine learning algorithms that have been used and are currently being used in the industry, some estimates say that around 80% of the algorithms, that the AI algorithms are actually machine learning algorithms that use traditional models that are statistics or probabilistic based models. And those don't use that much energy. They're pretty straightforward to train, to run. And it's not the same kind of architecture, the models, as artificial general intelligence or generative AI. And therefore, that's a different class of algorithms that can run almost on laptops, but on current cloud infrastructure. We don't need the new types of data centers that will consume a lot of energy to run. The question is, at which point will the usage of generative AI climb so high that it's going to become such an issue? I think there's an issue around the usage in terms of behavior, making sure that we use the right tool for the right problem. Do we use AI
for translation?
Every tool today, including Google Translate, etc., are using AI. Even Google Search, like one of the things that people used to say that, let's not use ChatGPT when we can use Google, etc. Now Google even has this, you can turn it off. But so I think everything is converging towards using generative AI in some sense, anywhere. So the question now is, how do we choose our tools and make sure that we use the right tool for the right usage? There's also this number that you might have seen coming out of an MIT study recently that says that 95% of the AI projects in the world are not successful. which means that only a very few number have the impact that they were estimated to have in the business world. So I think we really need to make sure that adoption is based on not just a blanket-wide rollout of AI, but we need to target it to specific use cases. And that's still a learning curve for both practitioners, users, and everyone.
Such a great transition to my next question, but I just want to come back to the 80%. So you were saying 80% of the project are actually classical machine learning algorithms, so the one that doesn't consume as much as energy. Do you think this balance is going to keep that way? Do you think it's going to change? How do you feel?
I think it's going to change just because, AI architectures are evolving very rapidly. We might think of hybrid models or models that converge between traditional machine learning and generative AI type of models, LLM-based models. LLMs are notoriously bad at quantitative analysis. So that's why machine learning makes sense on very quantitative analytical data like time series, for example, or tasks of classification, regressions, and those kinds of things. But we're seeing that LLMs, through reasoning, new types of architectures, are getting better at those numerical tasks, which means that if we're going to use these big, huge architectures to solve simple problems, where's the balance? We need to take more into account the energy and computational load of an algorithm. We do. And the question is, how do we make sure that the developers take that into account, given that, also the balance of handwritten code versus LLM generated code is going to shift radically in the next few years. We're already seeing a lot of change very rapidly in that area. Can we make sure that LLM-based code optimizes it for energy usage as well and uses the right library or the right tool for the right usage? That's not the case yet. And I think that's something that we need to look at very carefully.
Does it mean that we need like a collaboration, kind of making sure that these tools have the access to the right energy or the right technology to make sure that it works the best? Or is there a way to help?
Yeah, sure. Good transition to the conference series that I launched called Powered by AI, which is really at the intersection of AI and the energy transition. So we can talk about it later.
Powered by AI conferences, right?
Powered by AI.
Yeah.
And one of the sessions we had was on the energy consumption of data centers and how to use AI to optimize that. So there are ways to optimize the kind of algorithms that we're going to run for specific use cases or loads, or technical problem solving that we need to do. What's the most energy efficient way to run an algorithm, but also how to design data centers to make sure that they're more energy efficient, they consume less water, they can be cooled in a most optimal way, etc. So there are several behavioral, cognitive ways to do that. There's also a hardline way on design architecture, brick and mortar type of architecture, how do you set up a building housing a data center to optimize cooling needs, etc. There's a lot of avenues that we can improve. AI is going to definitely help in each of these use cases as well, making sure that we use AI to optimize AI usage, training, inference, etc. So it's a interconnected system, right? And the more complex it becomes, the more AI can help solve its own issues.
It's funny because we start more and more to talk about system talking to system and, technology helping technology. So it's funny. I was just going to change the order of my question to jump on that. So I'm wondering if another exec is listening to us today and he wants to start using AI, but not just to use AI, but responsibly in their company. Where should they begin? What's the first step?
We started our discussion about learning, right? Yes. Learning, education. I think that's one of the first steps, is really understanding what AI means. I think one of the things that I've been doing in my role at Engie, but also teaching at Sciences Po and other schools, is really around making sure that people understand what we mean by AI, because we all hear about AI. It's not very clear to people what it means, what's behind it. We have a lot of fears around AI. We see opportunities as well. We need to balance that out. We need to understand how we want to make sure that AI benefits the largest part of society, benefits also economic activity, the industry, that progress is based on the fact that AI has this very fast curve of progress these days. So how do we make sure that it benefits the most people? And that's very unclear at the moment because we have very different organizations or people with different agendas, different opinions on whether we should slow down AI or speed it up or keep it at pace. So I think at this time, it's mostly understanding what's happening, what the field is, understanding in terms of technology what it means. It can be quite simple. We don't need it to go into very hard math, but understanding what we mean by AI in general, and what are the use cases that we have today, what are the use cases that we estimate are going to arise in the next 5 years. how that's going to impact our jobs, how it's going to impact education in itself. I have two daughters, for example, who are in school, who use AI, starting to use AI in school.
By their own selves, or have been there, like
I
inside
think
it?
teachers don't know yet how to completely use AI.
True. Yeah.
So they're starting to use AI to help them prepare classes, prepare homework, etc. Students are sometimes using AI to solve their homework, which is probably not the right way to do it, but to help them understand how to solve homework, or to help them understand in different ways about a problem. And if they don't understand one way of explaining that problem, using AI to help another type of explanation that may be more useful for them.
Yeah, I feel like using AI to better understand is right. Using AI to get the solution is like you're not processing, so it's not really helping you. But when it gets you, help you to understand better.
I think understanding how AI can really help both in the educational setting, but also work setting. Is it to solve a problem and to automate it? Is it to help us better, what we're doing a lot through the IT revolution, through the digital transformation, through AI change that's happening now, is mostly improving existing processes, right? We take a process, every step of the way we automate or we improve the productivity. But what we really need to do and can do with AI is rethink the whole process end to end. Like, for example, thinking of email. When we email each other, it's to communicate information. But do we need AI to help us write faster emails? Or do we need to rethink how we're going to communicate information to get a certain goal?
Taking a higher view.
Exactly. And I think this higher view, this higher level of abstraction is really interesting, because that's what programming is becoming. Programming always was about problem solving. And we started with machine languages. We started assembly languages that were very close to the machine. And then as time went on, we had more abstract languages that modeled the problem better in the way that we represented them in business or in our minds. And now the way that we want to solve a problem through automated coding is to present the problem that we want to solve and to explain it the best way we can using natural language. Now we're seeing companies that are using PRDs, so product requirement documents, as an input to create code that will solve the problem that is described. So if you can describe a problem in the most precise way, then you can automate the resolution of that problem through automated coding. And that mind shift needs to happen. It's not just about solving things, it's about understanding what the important problems to solve are. And things like health problems, things like climate change, those are very complex problems. And those are things where AI can potentially help.
It does ring a bell. We used to be looking for solution, but now it's like, it feels like we're changing paradigm. And it's not about understanding the solution, but it's really about understanding the process, like understand the context and what can be done about that. Thanks for the hand, because actually if you're thinking about this is exactly the right place to be. So if you're looking for this kind of inspiration, you're in the good place. Stay with us. And it's funny because the next episode is about what is actually AI. We're going to be talking what is AI. Stay with us. I'm going to next to the next question. So you've deployed AI with so many use cases and so many industries. What's the most surprising lesson that you've learned and that still applies today?
So one of the things is that technology or transformation is never about the technology. It's always about people, right? Everybody talks about it. And I think involving people throughout the development process is something that we talk a lot about through agile development, through user-centric development, those kind of things. But I think in the case of AI, it becomes a very important paradigm where things are a bit turned on their head, in that it's not just technologists on one hand and domain experts on the other, or operational people who need a problem solved. Is that the people on the ground are going to be the ones not only defining, but building their own solutions. And therefore, the whole aspect about learning becomes incredibly important, because you need everyone to be able to understand how AI and related tools can help them in their day-to-day job, to automate parts of it, to rethink the process as a whole, because they're the best place to do that. And for developers and programmers, one of my core beliefs today is that they will need to become domain experts in one particular domain. That can change over the course of a career. We have all shifting interests.
We all have different lives.
Yeah, exactly. And I think what we need to do is not have expert programmers. I mean, that's going to reduce, I think, because of the tools we currently have and are going to have in the future. But we're going to have domain experts who know what are the important problems to solve, how to solve them using these tools, and how to collaborate between different pieces of equipment, different people, different teams. So collaboration becomes extremely important. It's not just solving problems in silos. Companies If Engie is the only one working on climate change and energy transition, we won't get anywhere.
Absolutely.
We need everyone to be involved, both industry, individuals, other energy producers, regulatory instances and organizations, etc. So it's all systemic problems. And to enable that collaboration, communication between those different players, a technology layer can help through sharing of data, for example, through sharing of models, through sharing of use cases. And then there can be a differentiation at the use case level on the application layer where everyone will have their competitive advantage differentiation. And that's what we're trying to do. So I'm part of research and innovation within Engie, trying to figure out what are the common foundational layers that everyone needs to adopt to speed up and accelerate the energy transition, where AI can help today and in the next 3 to 5 years. And what are the things that we need to focus on so that we maintain a competitive advantage on some things that are beneficial for our customers and users.
It makes sense. It's so important that actually I'm going to deep dive this topic with you in the French version of the, the episode. I'm also curious. I think we learned the most when things don't go as expected. I'm sure you had a project that didn't go as expected. What takeaway did you learn from it? Like what? If you have anything in mind.
No, I have, but because just a few months ago, we had this project that we have invested a lot in that sort of got decommissioned in some way, which is a bit raw, but let's talk about it. I think one of the things is a lot of AI projects that improve processes, improves ways of working and doing things may not have a clear value associated with them because it's very difficult to estimate the financial value, business value that can be generated from a particular use case. And sometimes it's very indirect things like if you're going to transform an industry, transform and bring change to a way process runs, or, I was talking about that predictive maintenance example. Those things are very difficult to measure the potential impact that it is going to have because you don't know if a piece of equipment is indeed going to fail or not. Is the deployment of that solution going to bring in a value and ROI in that field? So I think the lesson here is that in general, the KPIs and the metrics we have to take decisions on where to invest are still based on an old model, which is, is it going to generate revenue, decrease our cost, increase our top line, etc. Those may not be the right metric when we think about AI transformation in general, because it's going to transform the way we work, the way we operate our business. Some people in Silicon Valley have famously said that we're in an era where we're going to see the first billion-dollar companies operated by one person with AI agents associated with them. What does that mean for the future of industry? Because that's not the case always that a single person can operate heavy machinery. We're in asset-heavy industries where we have a lot of expertise that needs to be embedded in the way we train our processes. I think the understanding where we're heading, making sure that we take big bets, not just on measurable KPIs, but because we think that it's going to transform the way that industries work and operate. Is the energy sector going to remain the way it is today, the next 5 years? It's quite unclear. What are the disruptors? It's not very clear either, but we know that, digitalization and AI and data is going to bring a wave of change, and we need to be ahead of that change so that we can transform ourselves before other disruptors come from the outside.
We're so lucky to have you today because not only you are working on AI at Engie, but you're also sitting at boards so you can see like different people working with it. I'm wondering what would be the advice that you would give to people that are looking to use AI, not just for benefit, but for purpose?
So I think one of the things that we've been focusing on a lot, as talking about value, is also the fact that we are solving problems for end users. So we have this whole design-centric approach where we understand a pain point, try to solve for it, etc. I think that's shifting a lot towards process-based innovation, where we don't necessarily need to know who is going to be the end user because they have their way of doing things. A lot of the ways that people are doing things may not be compatible with other teams. So there's a lot of friction that happens between teams. But as long as we can use LLM-based models to treat that unstructured data, unstructured way of doing things, and make it something that in the background gets more structured through the usage of AI, I think we can maintain our ways of doing things without too much change. I think AI is a component itself in change management. We don't need to bring in a layer additional to that where we train people, where we change the way processes are run. I think AI and people hand in hand will transform the way we run things. But understanding that and implementing that, I think, is complicated because traditionally the way companies are structured, with various departments that more or less talk to each other. And, companies generally move from one organization to another every few years, because every type of organization has systemic issues and trade-offs that need to be addressed. So we think one way, everything is centralized, and a few years later, we need to decentralize everything.
Yeah.
And we all see that in large companies. And that's why startups have a high velocity advantage, that they can move very fast in one industry and address a market very specifically. But I think what happens now in terms of impact and the way we want to improve the world in general is finding the balance between very large structural change that large companies are good at and very small specific use cases that startups are good at. It's not just about use cases anymore, because it's no longer about solving a specific problem for a specific user. It's about process change. It's about systemic change. And how can we combine both the energy of startups and the firepower of large companies together through open innovation, collaborations, etc. It's an increasingly important way of collaborating and doing things. I think no one is going to be a huge player in the next 5 years if they don't collaborate, if we don't open up to other companies that may be competitors today. But we will need to collaborate on certain aspects in order to move forward together.
There are definitely some keywords I'm hearing. So collaboration is a key one, a strong one. There's this data. We were talking a lot about understanding. So learning from what you can learn from data, and then that will help you to optimize your processes, your systemic approach. So there are some keywords that it's like we're looping the loop. And then at the end of the day, it's all about learning to have a better impact.
It's about machines learning, and that's through AI algorithms. And it's about human learning as well. And we need to invent, learning goes along with innovation and creating our own future. How do we envision society moving forward? You were talking about how do we make sure that AI has a positive impact?
Yeah.
And
It's the
I
purpose
think,
of this podcast,
yeah,
is to
I think,
inspire for positive impact in society, environment, and business.
Absolutely. And I think they all go hand in hand.
Oh,
right?
yeah. It's all connected.
And I think regulation is one layer of it. Technology development is another. Societal impact is another. I've been talking to people coming from fields as diverse as mathematics or philosophy, talking about AI. And I think it's super interesting because everyone brings their own perspective.
Absolutely.
And I think we need to bring all that together to have a constructive discussion on how to make sure that AI has a positive impact, not just the fears that are behind AI on, what's the impact on jobs, what's the impact on learning, on, there's this other MIT study.
We all love numbers.
They've observed cognitive decline in people using ChatGPT over a very short time frame.
Yeah, I've seen that one. Yeah.
And it's a very preliminary study, so all these studies have to be taken with a pinch of salt. But I think it's interesting to see that there are those weak signals that could lead to massive impact. Human cognition, for example, it will have an impact. Social media has had an impact. We've seen that over several years. AI will also have an impact, but we need to get ahead of that. I think it's important to keep that in mind in order to think about what's positive in the technology that we're seeing.
I love how you bring this optimism and really realistic view. So I'm just going to finish with one last question. My last question is, what's the most exciting project you're currently working on? It could be an idea, it could be an experiment, anything you are actually exploring right now.
So one of the things that I'm thinking about at the moment is the fact that one way to bridge the gap between what's happening in the real world and the world of artificial intelligence is through what we call digital twins. The fact that we can represent reality through a physical model, that is a mathematical model or a physical or biological model using equations, etc. That for a long time, it was those types of equations that would run to simulate a type of asset or process or whatever it is. We're now thinking about using a hybrid approach where AI can complement those physical models, so augmented digital twins in some way. Some companies like Nvidia, for example, recently announced initiatives like physical AI, which is another marketing wrapping of digital twins in some way. But it's really thinking about how AI can help in physical computing, in computing things about the physical world.
So you're talking about robotics?
It can be robotics if you want actuators, if you want things that take action in the real world to create objects or modify the environment. It can be through sensors capturing data through IoT and edge computing, etc., to capture the world and then to influence it through robots, for example. But creating a mental representation or an artificial intelligence representation of the real world. And moving forward, I think in applications related to the energy sector, digital twins can be helpful, and more so than just specific use cases, because then we have a more systemic approach, and use cases can be building blocks of that infrastructure. And I'm thinking of something that would be some sort of energy operating system, is how do we create this software layer that represents the interconnection of systems that are part of the energy sector, the energy industry, from consumers to producers to prosumers, etc. And how can we leverage that to model and optimize the production and consumption of energy at a systemic level? So some sort of operating system that is a lower infrastructure that has digital twins as part of its building blocks and use cases as interfaces to people and to the real world. So it's sort of a abstraction of what's happening in the real world to the artificial world.
So it will be like a representation of the system connected together?
Yeah, it's going to be an AI-based model of what's happening in the real world so that we can think about interconnecting different systems. We can simulate things that are happening and see what their impact is on
with the systemic
different
approach.
assets, on different categories of users, customers, etc. So this interconnection of system, I think if we can rely on a common layer of data, of sensors, of input information, as well as models, then I think we can create this collaboration, this interconnection of systems that we need in the energy sector.
Coming back to the connection, right?
Yeah,
I love
absolutely.
that. Thank you so much, Mihir. It's been amazing.
Well, thanks for
you.
having me.
And I'll keep you for the French version.
All right, sounds good.
On est good.